Hello, this is Mr. Collier, and today we're going to be solving quadratic functions using our GDC. So I'm going to solve this one first using the HP prime, and then with the TI-84. So if you want to skip, if you have a TI-84, you may want to skip ahead a little bit until the part where I use the TI-84. Okay, so we're going to first have to type this into our calculator. So on the HP prime, when you want to graph something, you go to apps on function, and I'll clear these by going shift, and this is clear, and press enter, clears everything. So I'm going to type that in, so that's 2 plus, and then we need the absolute value. You can get a lot of stuff like that using this button right here. So I'm going to click on that, the absolute value sign's down here. And then in the absolute value sign, I could do 4 and use this x right here, minus 7. Then I'll arrow out to get outside the absolute value sign. Actually, that's all I'm going to type in for my first function. Okay, and the second function I will type in is just 9. So it'll graph the two separate things, and we're going to find the point of intersection to solve this equation. Okay, so once I have that in, I can go to plot. Now I can't see anything right now. You can use your fingers to try to zoom in or zoom out, but you can also do shift plot and change the domain range. So we have, I'm going to change this to go from -10 to 10, and hopefully I can see the graphs now. -10, 10. Okay, then I'll go back to the graph. Oops, plot. Okay, now I can see the graphs. The absolute value one is this blue one, and 9 is the red line. So it looks like there's 2 points of intersection. That means there's 2 x values that make this equation true. Okay. Now when we're doing a sketch, when we're doing this on a test, we want to draw a sketch of the graph. So I'm just going to sketch what that graph looks like. It doesn't matter. It doesn't have to be super accurate. You just need the basic shape for this. Okay, because the main purpose of the question is to find out the x value. Okay, so I'll draw the sketch, and we have 2 answers. I'm going to write them down here. Okay, so now to get those x values on the HP prime, we go to function, intersection is number 5, and I just click enter, and it gives me 0, 9 is this one right here. Okay, so that's that one right there. Now to get the other one, I will move my cursor to over close to where that one is, and then do function, intersection is number 5 again, and then I get 3.5 comma 9. 3.5, 9. Okay, that's the sketch. It's important though to remember that this is an equation with just x in it. So your answers is x equals 0. Actually, I drew that pretty wrong. It's supposed to be right on the y-axis here, right? Should be more like that. And x equals 3.5. So that's our answer. Our answer doesn't include the y values, right? So to do this on the TI-84, we will go to y equals. That's where we can graph stuff. Okay, I'll clear these things. I will type in 9, and I'll type in the left-hand side, which is 2 plus. And to get the absolute value, I think you can get it under math. You can also go alpha y equals, actually alpha, the second one here. There's absolute value. Okay. And type it in. 4x is up here, minus 7. Okay, and I'll just check my Windows settings are normal, -10 to 10. Usually that works. So I'll get a graph similar to the HP prime. And on the TI-84, to get those points of intersection, you gotta click on second and calc, and go to intersect as number 5. Okay, so make sure cursor is next to one of them. I think it's next to this left one. So I'll press enter, 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 and you get 0, 9, which is this one here. Make sure you draw the sketch. And then I'll go over closer to the other point of intersection, do the same thing. Second, calc, intersect, and press enter, enter, enter. Oops, I got the same one again. Okay, let's try that again one more time. I think it went back to there. Second, calc, intersect. Make sure the cursor is actually over here. Alright, press enter, enter, enter. And again, you get 3.5 comma 9. And write down the answer is x equals 0 and x equals 3.5. Okay, this next one, I'll probably just use the HP prime for number 1, and I'll just use the TID4 for number 2. So firstly, let's type in that function. Let me delete that. So it's 0.26 x squared minus 2x minus 3.1. Okay, I'll delete this 9 here. Okay, so I got the function typed in, and it asks for, well, is this graph pointing up or down? We don't need to look at the graph for that. The a value, the number in front of x squared, is positive, so we know that's going to be pointing up. And what are the coordinates of the vertex? For that, we will need to look at the graph. So I'll go to plot, and we can see the vertex right here. You can go to function, and it's called an extremum on the HP prime. Okay, so number 7, extremum means a maximum or a minimum. In this case, it's a minimum by looking at it. So if I click on 7, it tells me the extremum. It's 3.85 or 8.5. Let me draw a sketch. So actually, let me draw the sketch down here. Okay, well, that's horrible. Okay, so the extremum, or the minimum, is 3.85, comma, negative 6.45, was it? 95. Okay, so there's that. So that's 3.85, negative 6.95. The equation of the axis of symmetry is the same as the x value of the vertex. So we can write that in. What are the zeros of the graph? That's like the x-intercepts. We'll need to use our calculator for that. The y-intercept, though, you can get straight from the equation because it's in standard form. So the y-intercept is negative 3.1. Okay, so that's about there somewhere. There should be another point over here, I guess, because it's symmetric. Okay, let's get the zeros of the graph, or the x-intercepts. So on the HP prime, I can just click over at the x-intercept, and to get the exact value, you go to function, root. Okay, it's called root, so it's negative 1.32. Okay, so it's going to be negative 1.32, comma 0. And the other one, I guess, is going to be over here somewhere. So click on it over there and go to function, root again, and it's 9.01. 9.01, comma 0. Okay, I'll sketch the axis of symmetry too. And I'll label this this y-intercept. So I think I've got everything labeled, and the parabola looks like that. Okay, so the x-intercepts are negative 1.32, comma 9.01. Okay, next, so I'm going to do this one on the TID4. So I'll type that in under y equals. So that's 3.6 x squared plus 30.2 x minus 82. Okay, now that's a minus 82. Our y-intercept's going to be negative 82, so I'm definitely going to change the window. It's going to have to go down to at least 82. Let's do negative 100. And maybe we'll see what happens. Can we see the graph? Oh, I need to go down much further, and maybe a little bit more to the left. So if I want to go to the left, I'll change this to like negative 20 maybe. And the y minimum maybe needs to be negative 200 or maybe 150 would have been good enough. Okay, so now actually I want to find these x-intercepts too, and they're kind of squished on the top of the screen. So I want to see a little bit higher. I'm going to change that to 50. Alright. So now we can see it a bit better. Let's start filling in some things. We know the y-intercept is going to be negative 82. That one's easy. This is going to be pointing up because the a value is positive. And we'll need to get the other things with the calculator. So let me draw a sketch first. So it's going to look like that. Okay. And we already know the y-intercept. So let's get the other points. So the vertex first, we'll go to second, calc, it's minimum. Okay, so for left bound, you got to be to the left of it. And then you go to the right side of the vertex. Then to guess should be right on the vertex. And it tells you exactly the coordinates. So that's negative 4.19. Comma 145. Okay, so that's the vertex. Then we need to get the x-intercepts, also called the zeros of the graph. So we'll go second, calc, 0. And we go over to this one here, and we go to the left of it on the cursor. Enter, go to the right, enter, and for the guess, go right onto it, and we get negative 10.5, negative 10.5, comma 0, and the other one we have to do the same procedure, second, calc, and then 0, number 2. Okay, so we're to the left, and go to the right, press enter, and go over to it, press enter again, you get 2.16, so that's 2.16 comma 0. And I'll fill this stuff in here. This is negative 4.19 and 145. So the axis of symmetry is x equals negative 4.19. And the zeros of the graph are negative 10.5 comma 2.16. Okay, the last one. For the last one, this is basically solving the points of intersection of parts 1 and part 2. Okay, so let me do that on the HP prime. We've already got that function in there. Let's type in that equation from part 1, okay, which was basically this right here. Or this is part 2, yes. So 3.6 x squared plus 30.2 x minus 82. Okay, so we're going to find the points of intersection of both of those. Let's see if I can see the graph. You can see a point of intersection right here, but you can't see the other one because it's way off the screen. So we have to change our plot setup here. So remember, before I did negative 20, I think, for this. And I'll keep 10 here. Let's go down to negative 200 and up to 50. Okay, let's plot, and now we can see, oh, we still can't see that point of intersection, so I need to go up higher. If you got a touch screen, you could just probably use your finger and scroll up, or you can come in here and type in maybe 100 here. Okay, now I'll go to graph there. I want to get the point of intersection. I can click right here, and then don't take that number. You got to go to function and then intersection number 5. Okay, so it is negative 11.7 basically. Let me draw a sketch. So you got two parabolas, and they intersect in 2 points. Alright, so this one was negative 11.7 comma 55.6. And this point of intersection, I'll go click right on it, go to function, intersection, enter. It is 2.02 comma negative 6.08. Okay, so now looking back at the equation, it's only got x in it, so your answers are just x equals negative 11.7 and 2.02.